GIS stands for Geospatial Information Sciences, and it is essentially the management, the study, the use, all of that kind of combined of spatial data, and that can be applied to anything from what EHRA does here, like civil engineering, to things like public health, ecology, all of that sort of thing.
GIS, whether people realize it or not, it's all around us. We have GIS with our Apple Maps. That's geographic information. So everything really on this planet, I guess, can be construed into a GIS concept.
GIS here is a very integral part of what we do at EHRA, and really every day it seems like they get more and more involved. One of the big things that GIS works with Land Services is our TRIP program. That's Tracked Research, Information, and Planning. That's basically a database of all the tracks we have looked at for clients to see if they're feasible for construction of commercial, single-family residential, you name it. And it all starts at GIS.
We have a repository of data that we maintain kind of like all the time, but specifically with feasibility maps, we would get the information about where that tract is located from the engineer or whoever is requesting that map. Then we would look at what utilities are in the area, what municipalities are in the area, wetlands, any other kind of ecological factors or things that might factor into what a developer and their team would have to think about when you're working with a tract of land.
If it's in a floodplain, that's a concern, and they can see that on the map, or that it has a power line running through it. So things like that kind of help grade the tract.
Then we make sure that that data is current. We simplify it all down into a map and make sure everything is readable to anyone from an engineer to a layperson. It goes through a rigorous QA/QC process, and then we turn it over to the engineers and their clients.
And it shows all the boundaries all scattered out through the Houston area and other places in Texas. Basically, you know, if there's a boundary up there, we've done work on it. Well, you click on that boundary and it has all the information. We have a land plan, we have a cost estimate. This tract didn't work for this reason. They've set this whole thing up so that we can easily get in a meeting and quickly get to, you know, how many tracts do you have that are 20 acres? Well, there's a filter for that. How many tracts are 1,000 plus? Well, there's a filter for that. I only want to look at tracts in Harris County. Well, there's a filter for that. If I have a water line break, well, how deep is that water line? Where's the valve? Well, this database, they can pull it up on their phone, click, and they can see, oh, okay, there's a valve here, turn that valve off. Or sometimes you can't find manholes. They get covered up with dirt over time, 30 years over time. Well, you go and sit there and take your, cell phone and you find there's a manhole somewhere within a foot. Start digging, they find it.
With GIS, we can take an old map and we can geo-reference it to the same place where it was taken. So we've done old City of Houston maps and geo-reference them to their current place. And we can see like the progress of how things have changed since, 1900s to 2024.
My graduate degree is in GIS, and so what's really interesting to me is that you can use it for things like disease tracking. If you are a researcher and you collect the geospatial data of where that is and the timestamp, and then you collect a larger and larger collection, you can kind of see where things like diseases are moving and how fast and how intense they are. I just think that it's really fascinating how adaptable it is, and everybody uses GIS every day, whether you're using your GPS to come to work or like when Pokemon Go came out, like that's GIS. So I don't know. What excites me about GIS is the fact that it is so flexible and applicable to so many different fields across the board. You say the acronym and most people are like, what is that? But it's everywhere.